Hi Lincoln Middle Schoolers. Today we're going to go over how to measure accurately using the metric system. We have already gone over the metric base units, but let's review. So in order to measure mass, we use grams. In order to measure volume, we use liters. In order to measure length, we use meters, and length consists of length. We also measure distance, near and far distances with meters, and height with meters. We measure time with seconds, and we measure temperature with Celsius. Now, in order to measure mass using grams, we're going to use a triple beam balance. For this example, we're going to measure the mass of a penny that we've placed here on the left end side of the triple beam balance. On the triple beam balance, we have 3 beams, hence the name triple beam. There's one in the back that has grams in increments of 10, one in the middle that has grams in increments of 100, and one in the front that measures grams in singular values, 1 through 10. Now on the right-hand side of the triple beam balance is the balance portion here. Our objective is to get the line to line up with the 0. Then we know that it's balanced. So we're going to slowly move. First, we're going to try and move the 10-gram piece to the right. We quickly find out that that's way too heavy. The penny weighs much less than 10 grams. So we're going to move the single over slowly until the line is lined up with 0. When the scale is balanced, we have then found the object's mass. We're going to record using decimals. In this case, we find once the 0 is balanced here, we find that the mass of the penny is 2.6 grams. And we write this as 2.6 G. In order to measure volume using liters, and we use an L for short to represent liters, we're going to carefully use a funnel to pour our liquid into the appropriate sized graduated cylinder. In this case, we're using a 100 milliliter graduated cylinder. We're using this size graduated cylinder because we can look at our liquid and determine that this is the appropriate size. This amount of liquid we would never pour into a 10 milliliter graduated cylinder because it would overflow. Once we've poured all of our liquid into our graduated cylinder, which is shown here, just a portion of it, we're going to look at the meniscus. Now the meniscus is a new word. The meniscus is the lowest point of the surface line. So the surface line of the liquid is here. The lowest point is right in the middle. Wherever that is, the meniscus, wherever that is, we know that that is the volume. And we're going to record the volume using decimals. In this case, viewing the meniscus, the lowest point of the surface right here, we can come on over to the line and determine that the volume is 55 milliliters. And we write that in shorthand as 55 ml, short for 55 milliliters. This is also equal to 0.055 liters. In order to measure length, we use meters, the base unit meters, M for short. Now, it's not just length, it's distance, near and far distance, and its height. In this case, we're going to be using a meter stick. This is just one portion, and it's showing centimeters, 80 to 90 centimeters here. And once again, this is the portion of a meter stick. Now, it's important with length and with volume, as I should have mentioned earlier, to always be at eye level. For example, we're using a meter stick here to measure the height of the lab tabletop. We're going to lower our eyes or crouch down, kneel, to make sure we're looking straight at that number. Not down on it, not up at it, but straight at that number. Here's a zoomed in view. So we're eye level with it. And we're going to record using decimals. We're going to be as precise as possible. At this point, if we're to glance, we're going to see that it's at least 86. It's right around 86 centimeters. But we want to be even more precise, so we're going to look down even to the millimeters and see exactly what its height is. When we get even closer, I count 1, 2 millimeters. Therefore, the height of the lab tabletop is 86.2 centimeters, or 86.2 cm, which is short for centimeters. This is equal to 0.862 meters, or 0.862 m. We write for short. Now, in measuring the height of the lab tabletop, we use centimeters because that was the closest unit of measurement to the tabletop. And we can always convert to centimeters or to millimeters by moving the decimal point. Now, when measuring the length of the classroom, we use meters. It's just easier. For example, if it's 11 meters long, and you can see here these students are using meter sticks, several of them, back to back, right, to measure the length of the classroom. If it's 11 meters and then 78 centimeters, so it's 11 whole meters, and then almost a 12th meter stick, it's 11.78 meters long. Not 12 meters, almost there. So we're going to be as precise as possible and note the number of centimeters as well. Measuring temperature, we use Celsius, degrees Celsius, which we use a capital C for short. To measure temperature, we're going to use a thermometer, shown here, which we all know is very fragile and should be handled with care. We always take it out of the plastic casing, of course, before we put it in freezing water, boiling water, or any liquid for that matter. And we'll always suspend the end of the thermometer in the container or in the liquid. We're never going to have that end touch the glass or the glassware because then we're taking the temperature of the glass rather than the liquid inside. When taking the temperature of any liquid, you're going to keep the thermometer steady and suspended in the liquid, not touching the sides or the bottom of the glassware, and watch the red line. Watch it carefully, hold the thermometer steady. Once that red line stops moving, you've found the temperature. Record using decimals, be as precise as possible. The line has stopped moving. I'm going to gaze very, very carefully and notice that the red line is just past 20. However, it's not at 21, and I don't have any lines in between, so I'm going to come to the closest temperature, which is 20. I'm not going to round up to 21 because it's not there. It's never reached 21. I'm going to record this as 20 degrees Celsius or 20 degree sign Celsius, capital C, for short. When measuring mass, length, height, distance, volume, or temperature, it's extremely important to be as accurate as possible when taking these measurements and making the conversions. There's many examples as to why. One is if you were to mix two chemicals in your lab and they're mismeasured, you could cause an explosion, which would be terrible and go against all lab safety rules. What are some other examples and reasons as to why, as scientists and engineers, we would want to make extremely accurate measurements? Think about it.